Okay, so today we're going to enter into the realm of weirdness, and this is, like it says, change of variable and indefinite integrals is a fancy term. I commonly refer to them as UDU problems. This is about as close as we get to product rule, chain rule, and quotient rule for integrals. It can be fairly tricky. Now, unlike derivatives, where with derivatives we can pretty much take the derivative of any function we ever wanted to, integrals are very limited. So we will run into some problems that you just don't know how to integrate. Absolute value is one of them, for instance. We could learn that, but I'm not going to bother with it. But this is another realm that we can explore, and that is a UDU problem. And what the UDU problem does is it changes the integral that we have that we can't work with into something that we can work with. So the indication of whether or not you can do it as a UDU problem would be is it a chain rule? Is it a product rule? Is it a quotient rule? And then you have to make some choices. And at some point, you're going to choose poorly. The key here is choosing wisely. If you pick wrong, it's okay. You just have to erase and try it again. Okay. So I'll show you the procedure first, and then all this slideshow is examples. That's it. Okay? So we'll work through all of these together. All right, so let's start with this puppy. Up until today, we would not be able to solve this problem because it is a chain rule. You've got a function inside a function. So we're going to do a UDU problem. And UDU problems start with the following. You have to pick part of the problem to represent your u function. And in this case, I'll just tell you, it's 8x plus 5. Every UDU problem starts with a sidebar. So over here on the side in red, I chose u to be 8x plus 5. It might be wrong. What are my other options for UDU? And that's a question I'm going to ask a lot as I go through the examples. 8x plus 5 is an option. I could do 8x. I could do just plain old x. I could do the whole thing. And some of those are absolutely ridiculous. And so since this is our first one, I'm going to leave it like this. Okay, then I take the derivative over here. Now this freaks people out. I'm combining derivatives with integrals. du is equal to 8 dx. Implicit differentiation because I have two different variables. I have a u and an x. Step 3, solve for dx. Okay, so did I lose anybody yet? Are we good to go? We're good?
Where did the du equals 8 dx come from? Did you just take the derivative of 8x plus 5?
Yes, sir, I did. But again, since it's implicit, we need to have a du on there and a dx. Okay?
Wait, I think either I'm blanking, but how'd you get 1/8 du?
I solve for dx, divided both sides by 8.
Oh, okay.
Okay, all right, good. Everybody else good? Great questions. Now we do some substitution. Here's the easy part. I'm going to go back to the original function, and I'm going to sub in what I know. Well, I know that 8x plus 5 is u, because I chose it to be u up here. I know what dx is, because I solved for that here. And I'm just going to keep going because this is, you should know how to do this, but just in case. 1/8, 2/3 u to the 3/2 plus c. Don't forget indefinite integral, so that gets a plus c. And then our final answer would be 1/12 times 8x plus 5 to the 3/2 power plus c. Okay, questions? Does that...
Did you just plug in? Oh, you just plugged in on the last step there?
Yeah, I just plugged back in for u because we want it to be in terms of x, not in terms of u. Good. Any other questions? I started with something very simple. It's going to ramp up quite a bit, okay? But we're going to go baby steps here.
Mr. Reedy,
Yo.
how did you know u was 8x plus 5? Like,
Cut.
how did you decide that?
That's a great, Kaylee, if I could answer that question, I would be a genius. The problem is there's no straightforward answer to it. Number one, I've been doing this a while. Number two, I wrote the problem. To answer it as if I were a student, you don't know. But you'll see as you do more and more problems, you start to get an idea of what you want to choose for you. And I'm gonna intentionally set us up to fail on a problem just to show you what happens if you pick the wrong u. Okay, so I realize I didn't answer your question. The answer to your question straightforward would be trial and error is how I know. Okay? And be patient and then we can talk about it again at the end. Let's move on to another example. If you have something wrong with you, you could multiply this out. But again, I would suggest you seek professional help if you decided to do that. Therefore, we're going to do this using a UDU problem. So I'm going to give you some options for you. And then I'm going to ask somebody to pick u. For instance, we could consider this whole thing to be u, and that would be ridiculous. Okay, so that's silly. We could choose x to the fourth to be u. That's a possibility. We could choose 8x to the fifth minus 7 to be u. We could choose 8x to the fifth minus 7 raised to the ninth power to be u. We could choose just 8x to the fifth to be u. You see that there's a lot of choices here, which causes all kinds of anxiety. But we're just going to keep it simple. So I'm going to put somebody on the spot here. Let's see. Hold on. Okay. Cindy, let's put you on the spot. What would you like to try for you?
Is like 8x to the fifth an option?
It is. You want to do that?
I don't really know what to try, so we can just try that, I guess.
Okay, good. Let's do that. Now, I will tell you ahead of time, she's wrong. That's okay. We still love her. But don't write this down. I want to show you what happens when you pick the wrong u so that you can recognize, ooh, I screwed up. That doesn't work. Okay, so she said we're going to do u equals 8x to the fifth. Take the derivative. du is equal to 40x to the fourth dx. Solve for dx. dx is equal to 1 over 40x to the fourth du. Okay. Everything looks good so far. So now I do my substitution. I know what 8x to the fifth is. That's u. I have no substitution for x to the fourth, so I just leave it in there. And then dx is this mess over here. 1 over 40x to the fourth du. Now, Cindy, that wasn't a horrible answer. And the reason why it wasn't horrible is if you notice, the x to the fourth cancels with the x to the fourth. And so one of the things we did accomplish with her answer is we got all the x's to go away. Problem number one, if you choose the wrong u and you do your substitution and you have both x's and u's, you screwed up. Okay, but that's not what we have here. We have a nice equation with just u's. So what makes me say that she did it wrong? Well, the problem is we don't know how to solve that now. We still have a chain rule. So that creates a problem. Second way you recognize that you made a mistake is that you cannot take the antiderivative of the final function that you did after substitution. Okay, so questions about that before I show you the right way? All right, so let me erase. And tell you that she was very close. We want to take that. Okay. you'll notice in the problem, there's a term that is a fifth degree term, and there's a term that's a fourth degree term. A good rule of thumb is you want to take u from the higher degree equation, because when you take the derivative, it will normally equal the lower degree. All right, so I do it again. du is equal to 40x to the fourth dx I meant, dx. So dx is equal to 1 over 40x to the fourth du. So you're saying to yourself, well, what's the difference? I got the same answer that Cindy had. You'll see what happens in a second now. When we do our substitution, this becomes u to the ninth, x to the fourth, 1 over 40 x to the fourth, du. du. Whoosh, whoosh. So it's a subtle difference, but hopefully you pick up on that. I can take the antiderivative of u to the ninth. The x is canceled, so that's good. So now I'm going to end up doing 1/40th times the integral of u to the ninth du. And we can solve that. Okay? Questions?
Yeah. This might be kind of a dumb question, but what's wrong with the
There is
chain
no
rule?
dumb question. The only dumb question is the question never asked.
Okay.
I threw some.
What's
I threw some.
wrong with having chain rule?
We can't take an antiderivative of chain rule. In the very first day when we talked about integrals, no product rule, no quotient rule, no chain rule.
Okay.
Okay, good. Anything else? Beautiful. Next example. Oh. So I was feeling a little saucy. So I wrote a problem involving chain rule and a quotient rule. Okay, Bella, your turn. I'll give you some options, you pick. You ready? Would you like that to be you? Would you like this to be you? Would you like this whole thing to be you?
I think I'll go with just the x fifth plus 3x squared plus 5.
Have you all seen the third Indiana Jones movie? Has anybody seen the Indiana Jones movies? Oh boy. Never mind then. I'll find the clip so you understand what I'm talking about. She chose wisely. So let's get this mess out of the way. All right, du is equal to 5x to the fourth plus 6x dx. dx is equal to 1 over 5x to the fourth plus 6x du. Well done, Bella. Now, how do I know she's right? Because I've done the problem, but also you'll see as I start to do my u substitution. 5x to the fourth plus 6x over u cubed times 1 over 5x to the fourth plus 6x du. As you get better at this, you're not going to need to do this step. You'll be able to go from there right to the integral of u to the negative 3 du. And I'm not going to finish these because I'm assuming that you can take the integral. Remember, when you're done, however, you want to plug back in for u, because I want my answer in terms of x, not in terms of u. Questions on this one? Okay, so this is an example that if Bella had chosen the wrong u, we would get a substituted value that has both x's and u's, and that's a big no-no. But we're good to go. She did well. Or she done good, depending on how you want to phrase that. Okay? Next. All right. Time to strap on your big boy pants, or big girl pants, or big person pants. Try and solve that on your own. Go. Dog, you're awesome. You're welcome. Thank you. It's going to be a good day when Mrs. Knopke shows up with an iced tea for me. All right, Kev, we're going to pick on you.
I did something wrong because I have X's and U's.
Okay, so let's go through what you did wrong, because I think there's a lot to be learned from seeing mistakes versus just always doing it correctly. So tell me what you chose for you.
The cosine of 12x.
Okay, so you chose the whole thing to be u.
Yeah.
So du is equal to the negative sine of 12x times, actually be times 12 dx. Right? So this becomes the integral of u times 1 over negative 12 sine 12x du. Okay, good. So what I like about this is that Kev realized he screwed up, because again, notice I've done all my substitutions and the x's don't cancel. So that's bad. Okay, that's why we made erasers. Kev, any other ideas what we could try?
Could you do cosine x?
Nope, because you can't just make that 12 magically disappear. So that would be bad math. I'm going to stop you there. Any other ideas?
Could you do 12x?
Ooh, 12x might work nicely. Ooh, I'm happy. All u's, no x's, and it's something I can take the antiderivative of. You might want to do this. Which would give me 1/12 times the sine of u plus c. It is sine, right? Or negative sine? Which one is it? I forget.
I think it's sine.
It is sine, yeah, good. And then the last step, 1/12 sine of 12x plus c. Okay? scary, right? It's okay. You can admit it. You will get fairly frustrated. Kev, I would imagine that you were fairly frustrated when you did all that work and you realized, oh crap, I've got U's and X's, I screwed up. Again, that's why we have erasers. Oh boy. Now I threw this one out here just because I wanted to get all fancies in my pantsies, but the main reason I did it is because there are a ton of different choices for you here. For instance, I could do 8x. I could do cosine of 8x. I could do the sine of 8x. I could do sine to the fourth of 8x. I could do all kinds of different things. I will say that in this problem, you would want to do u, oh, that's a bad color. Let's go green. U equal to the sine of 8x. Remember that this is the same thing as the sine of 8x raised to the fourth power times the cosine of 8x dx. Okay, so I'm going to take this thing inside. du, whoa, du is equal to cosine 8x times 8 dx. Okay, now that step I did before on all the other problems, I'm going to skip that step now and go right to u to the fourth. Whoosh, whoosh. Okay, that was a big jump. Some of your heads may have just exploded, but you will get to the point where you can do that. You can skip all that, skip that extra step in there to do all the substitution. If you're not comfortable with that, then just stay with the pure substitution here. I have nothing to put in for that. I have something to put in for this, and I have something to put in for that. Okay, I also skipped a step over here where this would be that. Okay, so I went more quickly because I'm getting better at what I'm doing. And you're going to reach that same point.
Wait, shouldn't it be a negative cosine?
No, the derivative of sine is cosine.
Oh, okay.
Remember, we're doing derivatives, not antiderivatives.
Oh, yeah, that's right.
We good? Questions? Okay, so before we go on, what I haven't talked about is what happens if all of a sudden we're doing definite integrals. Okay. Now that opens up a whole new can of worms, and I think, in fact, I'm pretty sure that I did not assign any definite integral u to u problems tonight. If I did, postpone them, because this is not an easy conversation of how to handle definite integrals. We're going to save that for first thing tomorrow. Okay, so again, if a definite integral shows up in the homework with u to u, skip it. We'll come back to it tomorrow. Good? Yeah? All right, last thing, and then we'll take a look at day 44. Even and odd functions. We did this way back in the pre-calculus, or the pre-calc stuff in the beginning of the year. Even and odd functions. Remember that even functions are symmetric about the y-axis. So for instance, x squared is a even function. We talked about finding even functions by looking at the values of the exponents on each of the terms. If they're all even, it's an even function. If they're all odd, it's an odd function. And you'll recall that an odd function is symmetric about the origin, so it's the same right side up as upside down. Why is this relevant? It's not really, other than it's a time-saving tool. So this first part is easier to understand if we look at a graph. Okay, so there's the graph of x cubed. If I want to find the area under the curve from -4 to 4, I'm looking for this area and this area. What's the answer?
0.
0, correct. Okay. Now notice, the lower limit of integration is the opposite of the upper limit of integration. If it's an odd function, and we're going from a to negative a, your answer will always be 0. Okay. But it has to be, in other words, a to negative a of an odd function will equal 0. It's not so pretty with even functions, but they are symmetric. So, for instance, ooh, that's horrible. Okay. I want to go from negative 3 to 3. Hopefully you notice the answer isn't 0. But what you should notice is that those two shaded regions are the same. So this would be the same thing as going from 0 to 3 and multiplying it by 2. Stuff is disappearing from my board again. Okay. This, for even functions, is purely just a time-saving device. It's especially a time-saving device because it's usually easier to plug a 0 into a function than it is to plug a numerical value. The odd function, however, is huge. It's so much easier if you recognize it as being an odd function as opposed to having to grind out an antiderivative and plug in negative 4, plug in 4, and subtract them. It's also frustrating when you don't realize it's an odd function. You do all the work and then you get an answer of 0. Okay? Preguntas?